In order to really control type in your sketch, you need to know how large the characters are going to appear when they get shown on the screen. Processing gives us a number of function calls to find that stuff out. They're based on the standard ways that we measure type. So let's take a look at some standard typographical measures, and then we'll see the function calls that we use in processing to get that information. Here's a little string, big figs. Most of the characters are sitting on this line. This is called the baseline. There's also a line that tells us the height of most of the lowercase characters. This is called the midline. The distance between the baseline and the midline is called the x height, because it's typically the height of the character x, but it's also the height of a lot of other lowercase characters. Like here we can see it's the height of the character s. There are a few other lines going on here. Let's draw a line over the top of the capital letter at the beginning. So this line is just at the top of the capital B. You won't be surprised to learn this is called the cap line. The distance from the baseline to the cap line is called the cap height. Again, short for capital height. Notice though that the F sticks out above the cap line. And this is very common in many fonts. So we can draw another line at the top of the F. The distance from the baseline to this line is called the ascender height. That's because the tall top of the F that sticks out above the midline and above the cap line is called the ascender. Well, take a look at the two lowercase g's. They stick out below the baseline. These are called descenders. So the distance from the baseline to the bottom of the descender is called the descender height. So here we have 3 lines and 4 different heights. It would be really nice if processing gave us access to all of these different heights, but it only gives us access to 2 of them, the ascender height and the descender height. In order to find these values in processing, we have associated function calls. So if you call text ascent, notice that there's a capital A in there, you get back the distance from the baseline to the top of the ascender. And if you call text descent, you get the distance from the baseline to the bottom of the descender. These are the only 2 measures that we get. Unfortunately, we don't get to know the cap height and we don't get to know the x height. But much of the time you can get by using just these 2. By calling both of these functions and adding their values together, you get back the total height of the line from the top of the ascender to the bottom of the descender. Keep in mind that when you call text ascent and text descent, it uses the active font at the active size. So if you want to know the height of a particular font at a particular size, you need to make sure to make that active first, and then you can call text size to modify it. Then call text ascent and text descent, and they'll tell you the information about the currently active font. Okay, that tells us how high the font is, but how wide is this string? Well, of course, the width of the string depends on the string itself. So if I want to know the distance from the left edge of the capital B to the right edge of the S, in other words, the width of this string, I call text width. Notice that there's a capital W in there with the string that I intend to show on the screen. This gives me back a number, which is the width of the string big figs using the current font. These 3 function calls summarize everything processing is willing to tell us about the size of fonts on the screen. Let's take a look and see how to use them in action. Suppose I want to write this phrase. It's a very big pumpkin, where very big is in bold. So I actually have 2 different typefaces here. I have the normal lightweight typeface and the bold typeface, and those would be stored in 2 separate VLW files in my data folder. To show this, I would actually render 3 separate strings. First, I would choose to make the lightweight typeface active. Now I'll call text and tell it at this point, print it's a. Now I switch and I make the bold typeface active. And then I tell processing at this point, type out very big. Finally, I'll make the light typeface active again and tell it at this point, print out the word pumpkin. In order to find the locations of these 3 red dots that tell me the bottom left corner of each little phrase, I need to find the width of these different strings. So I'll say width 1 is the width of it's a, followed by a space. Width 2 is the width of very big in boldface, followed by a space. If I add those together, I get the horizontal location of the red dot that begins pumpkin. All right, let's actually see this in action in real processing code. So first, I'm going to make the plain font the active font, and I'm going to find the width of its including the space, and I'll save that. Then I will make the bold font active, and I will assume that I've made plain font and bold font by calling load font with the appropriate VLW files. To find the width of very big and bold font, now I just call text width, and it's using now the bold font. Now let's go ahead and draw the string. I'll say that the left edge of the string, the beginning of the word it's, is going to be at 100. First thing first, we make sure we go back to the plain font, because at this point the bold font is still active. So we go back to the plain font and we call text. The string I want to display is it's the X position is text left, and the Y I'll just say is 100. Now I could switch to bold, display very big, and switch back to plain and type out pumpkin, but you know what? I've got the plain font loaded, so let's do pumpkin now. We know where it is. It's the string pumpkin, and its left position is text left plus width 1 plus width 2. That tells me where the word pumpkin begins, so this displays it. So at this point the screen says it's lots of space, pumpkin. We now need to fill it in, so I'll switch to the boldface, and I'll type very big at text left plus width 1. All of this code together will print out what we see at the top. Just for fun, suppose we want to display very big in some red color. So let's take a look at very big. We'll switch it to red. How do we do that? We'll look down at the last line of the code. Just before we actually display very big, I'll open things up and I'll put in a call to fill. Whatever color we're filling with, that's the color of our type. So now this is the code to print out what we see at the top. It's and pumpkin in normal typeface, and very big in red bold. Keep in mind that when you start a new sketch, the default fill color is white. So all of your text will come out in white. If you want your text to come out in black or some other color, call fill before you call text. So let's summarize what we've seen. Here's a typical string. There are 3 things we get to find out. The text ascent tells us the distance from the baseline to the top of the ascender. Text descent tells us the distance from the baseline to the bottom of the descender. And text width with a string tells us the width of that string. These are all with respect to whatever font is currently active. So if you want to know this information for 3 different fonts, make one of them active, call these things, make another one active, call them, make the third one active, and call them. And they will always tell you what's going on with the currently active font. With this information, you now know where things are going to show up on the screen, and you have much more control over how they're going to appear in your sketch.